All right, Thomas Dimitrovich here. This is a recorded session. Why? Because I'm in Bonn, Germany. And I thought, as I was traveling, when I got to the UK, and then I got into Frankfurt, and now I'm in my hotel room, I was looking for receptacles and trying to figure out how to make this stuff work. I thought, why don't we talk about receptacles? So today's topic for IAEI News Live is on receptacles, and it starts right now. All right, so if there was ever a workhorse component in a power distribution system, whether it be a residential, whether it be commercial, industrial, it doesn't matter. We need receptacles. We plug things in. It doesn't matter if you're going to an office, if you're going to a plant floor, if you are working at your desk or maybe even in a kitchen. You need a receptacle. Well, you know, on my trip out here to Germany, I think I take some things for granted. I was lucky enough that I purchased the right product, and I didn't realize how right it was until moments ago as I started to plug all of my equipment in. So that's our discussion today, and I had a completely different topic all lined up I was excited about, and I'm gonna have to do it a different day because I got more excited about this. I thought, man, you know, it might be a great idea to just because I'm gonna have to record this. Now I'm going to record this, and because I'm 6 hours ahead of 12 o'clock Eastern, so this goes on at 12 o'clock Eastern. And I gotta make sure I set this to go off right. But I'm 6 hours ahead of 12 o'clock, so it'll be 6 o'clock p.m. here in Germany when it is 12 o'clock Eastern. And I might, if I'm not out with a customer or two, I might be able to dial into this session. So I don't know, chat it up. Please use the chat. We learn together on this program, and I really appreciate every one of you dialing in and for the discussion and engaging. So please engage with the discussion. Let me know what you're thinking, and let's talk about this thing that we call a receptacle. Now, what I'm going to show you here, over here is our images from my room, and they're images of the receptacle that you'll find in this type of an environment in this country. A little different, and it's inset. You'll notice it says 220 volts, and the adapter that I purchased is actually something that is I was lucky that there was a separate little adapter that, because these receptacles are inset, I needed to get those two holes brought out to the front, and then I was able to plug that adapter in. This is a type of device that I'm used to using in the past, and it has on the back various configurations that you can apply. So I can, based upon the country that I'm in, I can take this piece of equipment, this device, and I can have the prongs that you see here, or in this case here, I have a 3-prong, and these two are straight, or I can turn them so they're diagonal, and then there's a center post that can come out. It's just configurable. And what I like about it, it has a 3-prong in the front, it has 2 USB ports, and then a 2-prong here. I used it on the planes. Depends upon where I was at. When I was in Japan, I used this heavily. So, but I couldn't use that until I had this other adapter, which, man, thank goodness I bought that other adapter. But all of thinking about this and how you lay out these rooms and how the electrical distribution systems are different from country to country to country, standardization is so important. It is so important. And it's not until you travel abroad that you start to realize that standardization, we enjoy the benefits of standardization. When you plug your receptacle into any building that you go into in the United States, and they enjoy that over here as well. We don't have standardization between the United States and Germany and the UK and Japan and all of these other different countries. It would be great if there was that level of standardization. We enjoy standardization on many USB. I think that's almost like the universal receptacle that I can find right now is a USB, whether it be a USB-C or what. It just seems that you can find those types of receptacles across the country where 120 volt, not happening. You need some adapters. So in any case, I had this idea. I thought, I'm going to set up in my hotel room and I'm going to talk a little bit about receptacles. And we'll take a look at some sections in the code. So get your copy of NFPA link. You can open two windows. You can watch this in one window. You can open NFPA link in another window. Because I'm going to open it in another window as well. And then, or if you have a book, get your code book out, because we're going to probably do some code references here. Now, mind you, please, some act of forgiveness here. I've been up for over 30 hours so far. I haven't hit the bed yet because if I go to bed now, I'll probably wake up at 3 o'clock in the morning, be wide-eyed, and then I'm going to be really super tired tomorrow afternoon. So I'm hanging in there until I go to bed on a normal time here in Germany, and then when I wake up in the morning, I'm on German time. So European time. So that's the plan. I don't know if it's going to work or not. But so receptacles. Let's just talk receptacles. Receptacle, in my opinion, the receptacle is another one of those workhorse components, electrical items, pieces of equipment that it's a workhorse in our industry. It's like the transformer. It's like the lighting. I mean, if you think about a receptacle, you need a receptacle regardless of the industry you're in, whether it's a residential dwelling unit, a hospital, a commercial building of some sort, an industrial facility, even in industrial equipment or industrial control panels. We see receptacles all around us. We see 120 volt receptacles. We see 240 volt receptacles. We see USB receptacles. We see GFCI receptacles. We see weather resistant receptacles. There's so many receptacles. It's just the opportunities are all around us. And we have to understand how to apply those. We have to understand what they are, how they function, some of the terms and definitions. So we're going to talk a little bit about that today. I had a completely different topic that I was planning to record for today's session. And in fact, I recorded it. And I didn't delete it. I threw it out because I'll probably just do it live. And I'm recording this session because, I think we take them for granted. I really do. It's a complicated little thing, but we use it so much. So that's what I want to focus on. So what I'm going to focus on are the 15 and the 20 amp receptacles. So you have these two rank the highest on my list. Like I say, you'll find them in dwelling units, you'll find them in commercial buildings, you'll find them in just about anywhere. So I think it's worth a peek at the fundamentals, the basics. So we're going to talk basics here. Now, the first thing is standards. From a standards perspective, UL 498 is titled Attachment Plugs and Receptacles. That's going to be your primary reference for our discussions today. Obviously, the National Electrical Code, so get your NFPA link opened. You can put it side by side in Windows, or grab your copy of the code book. I've got my iPad and I've got NFPA link. I'm going to do a side by side. That's just like I told you to do. I'm going to do split view. And then I'm going to open up my browser, and there she blows, Cupcake Island. I'm going to do it this way. I'm going to split it right down the middle. Use my handy dandy pen. Well, it's not letting me split it. Well, I'm split, but it's not letting me enlarge the NFPA link window. So let's make it smaller, and let's do it again. I'm going to split view and bring up, there it is. So it wasn't NFPA link, it was me. So the National Electrical Code, we're going to be looking at that, and hopefully you can follow along. So grab your physical code book, go out there to get an NFPA link, whatever. Another reference, CSA C22.2. Now, that title of that document is General Use Receptacles, Attachment Plugs, and Similar Wiring Devices. So this is the Canadian standards document that governs the performance requirements for receptacles and attachment plugs and similar wiring devices for use in Canada. So you've got CSA C22.2 and you've got UL 498. Those are the two standards. One is United States, one is Canada. Now, the other one is Federal Specification WC 596. This is the General Specification for Connector Electrical Power. The document includes additional mil-spec references and testing requirements. So those are going to be my four basic documents. I could probably dig up a host others, but I'm only going to focus on those. That's all I'm giving you for your library. So focus on those four. And I would say you're not going to go out and buy UL 498. Go to product spec on the web from UL, and you can get the information for receptacles for the application that basically pulls out of UL 498 what you need to know to apply that product. Now let's take a look at, in chapter 1, let's take a look at the definition of a receptacle. All right, so the definition of a receptacle. Remember, the 2023 code moved all definitions to the front. Now, there are a couple. So the first definition I want to look, the first defined term that I want to look at is the term receptacle. Now, it says, and it did not change during the 2023 code cycle, a contact device installed at the outlet for the connection of an attachment plug or for the direct connection of electrical utilization equipment designed to mate with the corresponding contact device. So that is very generic. That means that it's any type of contact device. It doesn't have to be what you're probably picturing in your mind with regard to a receptacle. It could be any contact device. Then it says a single receptacle. Oh boy, this is important. And people just, sometimes, I don't know, sometimes people don't get it. So, a single receptacle is a single contact device with no other contact device on the same yoke or strap. Now, remember, when you have what we know as a duplex receptacle, When you have a duplex receptacle, there are two receptacles on a duplex receptacle. Is not a single receptacle. It's not a single receptacle. It's what the definition calls it. It's a multiple receptacle because you have two receptacles on the same yoke. You can get a single receptacle, but you can also get multiple receptacles on the same yoke, and that is multiple receptacles. It's not a single receptacle. So if you in your mind are picturing with regard to a single receptacle, a duplex receptacle, that would be incorrect. And in some cases in the NEC, when it calls for an individual branch circuit supplying a receptacle, that's not a duplex. You can't put a duplex. When it says supplying a receptacle or with a receptacle, that means singular, that's one. That is not a duplex receptacle. That would be two. All right, so that's the definition of the receptacle. Understanding the parts of a receptacle. That's another important thing to wrap your head around. Take a look at that receptacle. Understand that you have what the yoke is, how that's assembled. Because we use that yoke for a couple different things. Obviously, we use it to hold the receptacles together, but we also use the yoke to hold the receptacle in the outlet. Now, okay, so while not prevalent, there are non-metallic yokes. You may or may not have seen them because they're not very prominent. They're not, you don't see them every day, but they're, the yoke doesn't have to just be metal. So just to tell you how it's used, section 210.7, 210.7. Go to your NFPA link and look that one up. 210.7 is multiple branch circuits. If two or more branch circuits supply devices or equipment on the same yoke, duplex receptacle, or mounting strap, a means to simultaneously disconnect the ungrounded supply conductors shall be provided at the point at which the branch circuits originate. So if two or more branch circuits supplying devices or equipment on the same yoke, think about how do we get that done? We take a duplex receptacle and we break the tabs, separating the top receptacle from the bottom receptacle. Now those are both independent receptacles. What might we do? We have two breakers, two branch circuits, one feeding the top, one feeding the bottom. Maybe the bottom is a switched receptacle, and maybe the top is not a switched receptacle, or vice versa. You have to make sure that when you turn the breaker off, you must turn both of those off because both branch circuits land on the same device. We don't want someone to turn one breaker off and end up having an energized part out there. Now, I will tell you while we're talking about it. I guess I'm going to ask the question, but it's facetious because it's a recorded session and I don't have like a Mentimeter tool. But does the code mandate pin up or pin down? What do you do? Leave it in the chat. Whenever you install, do you put the ground pin up or do you put the ground pin down? What's your preference? I would love to know how you treat it. But in any case, back to the discussion. In some cases, And I know some electrical contractors, not code driven. It's more of a I don't know, a general practice, so to speak, where they will take for the switched receptacle. If, for example, they put all the pins down, all the ground pins down in a, say, a residential dwelling unit, the switched receptacles will have the ground pins up. That way they know to spot the switched receptacles very easily. Do you do that? Do you think it's a good idea? Do you think it's a bad idea? And if you put the ground pin up, would you consider putting the ground pin down for those switched receptacles? I just thought it was kind of cool. I thought it was kind of neat. But in any case, 210.7 tells us when we have multiple, you need to open them both. Let's take a look at okay, so now in the previous text, in the previous NEC, previous edition of the National Electrical Code, in Article 220, if you look at, where's my Word doc? There it is. So if you look at if you have a 2020 edition or earlier, take a look at section 220.14. 220.14 is titled Other Loads, All Occupancies. Now, 220.14I was an occupancy. Oh, wait, maybe it wasn't. 220.14I. Take a look at 220.14I. I might be getting ahead of myself. 220.14, let's take a look. I know we pulled residential out of there. We pulled hotels and motels out of there, but I don't know that I can apply that. I mean, no, receptacle outlets is in there. So that wasn't moved. But it did make a slight change to the language, but 220.14I, except as covered in 220.41 and 220.14J, receptacle outlets shall be calculated at not less than 180 volt amperes for each single or for each multiple receptacle on one yoke. Now, in this case, they're treating a multiple receptacle on one yoke and a single receptacle on one yoke the same. It's still 180 VA per those individual units. So remember our discussion where we said a multiple receptacle in some cases may be treated separately. If the code talks about a single receptacle, you can't use a duplex. In this case here, the 180 VA, whether you're a multiple receptacle, which means you can have two or more on the same yoke, you treat that as 180 just like you would a single receptacle. A single piece of equipment consisting of a multiple receptacle comprised of 4 or more receptacles shall be calculated at not less than 90 VA per receptacle. So if you have a single piece of equipment that consists of a multiple receptacle comprised of 4 or more, then you're doing 90 VA per receptacle. The provision shall not be applicable for the receptacle outlets specified in 210.11 C1 and C2. Now, okay, so you have to understand what a receptacle is. You have to understand what a multiple receptacle is to apply the load calculations in 220.14. So be mindful of that. All right, so let's continue on our journey. Now, if you think about the standards. Now, what does a UL standard do? A UL standard will take a product and put it through what we call performance tests. They don't have prescriptive tests. They don't tell you how to conduct something. They don't tell you how to manufacture something. They subject the product to conditions. And then you have to perform, right? So some of the product tests, some of the key performance tests requirements that we'll find in the UL standard for receptacles include these 5. Well, we'll start with these 5. So that's the retention of blades. I don't know about you, but in some locations, especially you go to some hotels and whatnot, where these receptacles might be heavily used, and you plug your computer in and you watch the plug just fall back out because there's no tension. So that is a test point. That is a performance criteria for these receptacles. And what it says is after 10 insertions, not to exceed 40 pounds of force of a standard steel blade plug gauge, the receptacle must be able to hold a polished steel 2-blade plug gauge without holes against a 3-pound force for 1 minute. The receptacle must release a polished steel 3-blade plug gauge with holes at not more than 15 pounds of force. Now here's the problem. That's great when it's new, but over the years it will get worse. And that's when you need to determine, when am I going to replace it? So a second performance standard requirement, current overload. The same test from the retention. So here's another thing that you'll see in standards. They will run a product through a test and then use that same product after it goes through that previous test and put it through some more tests. That's what they're doing here. They take that retention and then they do an overload test. And the test sample device is subjected to 100 insertions and removals of a mating plug, making and breaking DC current through a resistive load at 150% of the device rating. Dadgummit. The blade of the attachment plug is to mate with the contact of the receptacle for not more than 1 second during each cycle. So they want you to continuously plug, unplug, plug, unplug, plug, unplug, and that is for 100 insertions and removals. Then they do a temperature rise test. So after those other 2 tests, then they do this. They take those same samples, they subject them to a temperature rise test. They strategically place thermocouples to ensure the test subject passes the test, which requires the contact temperature rise of a flush or self-contained receptacle not more than 54 degrees Fahrenheit. And then they do a repeat blade retention. So all these test samples, they're going through test after test after test. Then you go back and you repeat the retention of blades. So you did the retention of blades, you did current overload, you had current passing through it, and you were plugging and unplugging it. Then you did a temperature rise test, and then now you're doing the blade retention test again. I'm getting tired just thinking about it. Resistance to arcing. The outlets that were subjected to the 100 cycles of operation in the overload test described in the item above must perform acceptably when subjected to an additional 150 cycles of operation under the overload test conditions. You just keep beating it up. You keep beating it up and it can't fail. I think it's worth noting that this level of redundance that we're seeing in this receptacle, it's not unique. We do this in many other standards. So other standards, and for this product as well, we take this redundancy and we like to beat them up for other ways that products might be listed. Hospital grade is a good example of that. And we'll talk about hospital grade as well. All right, so here's some more. Terminal strength. The standard 3-prong steel test gauge is inserted 10 times and the maximum insertion force should not exceed 40 foot-pounds. If the receptacle has a break-off tab, it is removed prior to the conditioning. After conditioning, each terminal is wired with the number 12 solid copper wire by applying 14 inch-pounds of tightening torque. The wire is stripped, etc. So they go through that. Then they go through the grounding pin retention. So this is subjected, they take the grounding pin and subject it to various situations, including a weight of 5 pounds located 6 inches from the outlet face. Gosh, nets. And then you have fault current. They'll run it through 1,000 amps. So the standard receptacle is tested at 1,000 amps, short circuit current rating. Then you do a dielectric withstand test. That's at 1,000 volts. That's for tamper-resistant receptacles. A dielectric test is performed to determine the effectiveness of the device's insulation. That's for your tamper-resistant. Then they go to mold stress relief. They have an unwired receptacles, and they're subject to 70 degrees C for 7 hours. And after being allowed to cool, they take measurements to see if there's any warping or shrinkage or other distortion. This is just a receptacle. Think about what it's going through. It's insane. Then assembly security. This test is grueling in that the subject receptacle has to endure 50 pounds of force through extra long blades inserted into the receptacle and directly on the back of the receptacle. Wow. That is a lot to put this little guy through. That is absolutely a lot. All right, so then we get to the hospital grade. Now, then we get to the hospital grade. I just need to plug you in. Now, we've all seen the hospital grade. We know they're used in hospitals, for goodness sakes. We plug you in. There. Is that better? All right. In addition to all of those tests in UL 498, they have a supplement for product requirements addressing other application needs. One of those is a hospital grade receptacle. They do an abrupt plug removal. They take, oh, man, they take a test plug with brass blades and they attach a 10-pound weight to it. Insert it into the receptacle. The weight is dropped from 24 inches, a total of 8 times, in an effort to abruptly remove the plug from the receptacle. Give me a break. And then after that, they can't experience any breakage that exposes live parts, and it has to be able to be mated to a standard plug and retain a 3-pound weight using a standard 2-prong plug. That's an additional test on everything else that we've done for receptacles. Then they have the grounding contact temperature. Use the same devices, the same ones as tested above, and then they demonstrate the grounding path in a receptacle by a temperature rise not exceeding 54 degrees Fahrenheit when subjected. They take 8 receptacles previously tested to a continuous current of 25 amps for 1 hour, then 22 amps until equilibrium is reached after being wired in series through the grounding conductor path. And when you think you're done, there is a fault test. The subjects that have been previously tested in the above 3 tests, then subjected to the standard fault current test, and the grounding path has to maintain its integrity. Then you have grounding contact overstress. After an oversized steel pin is inserted 20 times into each ground contact, each ground contact must retain a standard sized polished steel pin against a 4-ounce force of 1 minute. Then you have terminal strength. It's basically similar to the above with they have different size and different foot pounds for torque. Assembly security, and then this is the assembly security test of the standard receptacle, which is performed with a 50-pound force, is now done with 100 pounds of force. Wow. I wonder if they put like a little towel around the shoulders of this thing and like every now and then pat it on the back. I don't know if you have to talk to it throughout the whole thing, tell it how good of a job it's doing. It's insane. Then you have the impact test. The receptacles are installed in a metal box outlet with a metal faceplate with the outlet facing up. Then a 5-pound weight is dropped from a height of 18 inches, impacting the center of the receptacle outlet. You can't have any breakage that impairs the function of the receptacle or insertion of a plug. And then finally, you have an increased mold stress relief. Unwired receptacles are subjected to 7 hours, 90 degrees C. And after being allowed to cool, measurements are made where there shall not be any change in the dimension greater than 10%. Wow. That's a hospital grade. The hospital grade goes way over and it goes well above and beyond. And then you, obviously to pass most of those tests, you're probably going to have to beef your product up a little bit, I would assume. All right, so the federal product information, so the Fed spec product performance criteria, they do 9 additional tests for mil spec. Gripping power blade, grounding blade. In this test, an oversized blade is inserted and removed 20 times into the current carrying contact. Then each current carrying contact has to retain a less than standard thickness steel blade secured to a 1.5 pound weight for 1 minute. Think about this. And they do the same thing for the ground blade. Now, there's a terminal strength. It's similar to the hospital grade, except that the terminal is tightened 5 times onto a minimum and maximum wire, 14 to 10, and then tested by hanging a 20-pound weight from the wire for 1 minute. And then they do an overload 200% AC. The plug is inserted and removed from the receptacle 250 times, as compared to the 100 times for UL 498, before conducting a 200% rated current test. UL 498 only requires the test to be run at 150%. So this additional test for the federal spec is much more significant. And then they do a temperature rise, repeat blade retention, dielectric voltage withstand 1,000 volts, insulation resistance. The insulation resistance when measured at various points on the receptacle shall not be less than 100 megaohms. Heat resistance. Unwired receptacles are subjected to 85, oh man. Unwired receptacles are subjected to 85 degrees C for 2 hours, and after being allowed to cool, it has to have no mechanical changes to the dimensions. Assembly security. This is basically they take 100 pounds of force through extra long blades inserted into the receptacle, as well as 50 pounds of force to break the bridge of the receptacle. All right, so there's another product out there that I know about. It's the tamper-resistant receptacle. So how did the tamper-resistant receptacle come about? What we learned back in the day is the statistics around what we see with kids, basically, putting objects into receptacles and being burned. So they had a lot of information and statistics that demonstrated kids are going to be putting things into those receptacles and they're getting hurt doing it. So we came up with a technology called a tamper resistant receptacle. Can't call it tamper proof, call it tamper resistant. And what a tamper resistant receptacle does is basically you can't put an object into one of those two slots. You have to actually figure out how to simultaneously put pressure on those little doors that are in there to be able to get anything into that receptacle. Now, when they first came out, there were complaints that, look, I can't put my receptacle, my plug in because it's difficult. And in fact, even at some state adoptions, there were claims that, elderly would not be able to use a receptacle anymore, which did not pan out at all. None of that was true. So in any case, the tamper-resistant receptacle was born out of the statistics around the number of kids who get hurt on putting things and items into those receptacles. I'm sure there's probably a few grown-ups out there too. But anyway, that's ungood. You can't do that. You shouldn't do that. Please don't do that. So when they came out with the tamper-resistant receptacle, they realized we have to do more tests on it. So they did. So they have additional tests for the performance requirements for receptacles, for specifically tamper-resistant receptacles. They have to apply with a probe test. Now you think about it. You want to keep someone's fingers out. You want to keep objects out. Well, you need a probe test. And the way the probe test is written, the test starts fresh with 12 untested devices. A probe is used, applied to each of the receptacle's slot openings at a force of 8 ounces. The test attempts to bypass the tamper-resistant mechanism by manipulating the slots in any orientation. Another one is an impact test. This test uses 6 of the 12 devices used in the previous test and subjects them to either a ball pendulum impact or a vertical ball impact test, which strikes the receptacle face or tamper-resistant mechanism or other. The test is trying to determine the risk of fire or electric shock. All right, and there's some more details with regard to that. Then they do a mechanical endurance test. This is 6 devices which were previously subjected to the above probe test. Oh my God, those poor devices. Gosh. A machine continuously inserts and withdraws for 5,000 repetitive times. An attachment plug having secured solid brass blades. So think about it. Some of these receptacles go through a heck of a lot, and this is a tamper-resistant receptacle. And then they do a dynamic voltage withstand test. Because, again, you want to make sure that as you're putting these products through tests, you're subjecting them to some harsh activity. Then you want to do some validation that there's no dielectric breakdown, there's no chance of something faulting to another conductor internal to that unit and how you do a dielectric test is you impress a very large voltage on it. So be mindful of that. So that's basically, what I just gave you was I gave you an overview of a regular receptacle. I gave you an overview of a tamper-resistant receptacle and also a hospital-grade receptacle. All of these tests must be performed, and depending upon the product that you purchase, those additional tests are there to make sure that that product can withstand some of the heavy-duty treatment it may get in an installation. All right, so let's talk about the receptacle configurations and classifications. This is where we're going to get into the NEMA discussion. So NEMA has some standard configurations, and quite frankly, this is sort of where we get into differences between Europe and other countries versus the United States and Canada with their unique configurations. So a NEMA 1 is good for a 15, 20, and 30 amp. A NEMA 5 gets you up to a 50 amp. How about a 5 ALT, which is an alternate construction for a 20 amp receptacle, which prohibits a NEMA 5-15, which is meant for 15 amp circuits. You have the 5 ALT. So the 5 ALT is an alternate construction for 20 amp receptacles and prohibits a NEMA 5-15 device, which is meant for a 15 amp circuit from being inserted. Then you have a NEMA 6. Then you have a 6 ALT, 6 alt. You have a 7, the voltage is indicative of lighting loads. You have a 10, typically seen on a roof and extensions, homes for dryer circuits where no ground was present. Then there's a NEMA 11, electric motors and other similar equipment with no ground conductor. A NEMA 14 is typically seen on new dryer type circuits. And a NEMA 15, basic electric, basic motors and other similar equipment with a ground conductor. So the configuration, we have different types of NEMA configurations, and these NEMA configurations are used in NEMA markets. And the consistency of this, here's the challenge. You have a receptacle that's made by one manufacturer, and the plug that plugs into that receptacle is made by a different manufacturer. Hence, you need tight tolerances, you need testing done, because those blades on the other plug, now they should be following the same standards. It's just important, the whole aspect of codes and standards, putting products through their paces and making sure that they fail safe and they don't fail in a situation that could cause heating. That's what we're talking about. So, what else? So here is okay. NEMA manufacturers of different offer different grades of products, and some are driven by product standards, but others might be driven by the market requirements. So you have standard grade, you have specification grade, you have construction grade, you have hospital grade, you have industrial grade, you have commercial grade. There is a host of receptacles, and then you sit down and go, well, which one do I buy? Right? So if you ever have questions on that, call the manufacturer, call one of those wiring device manufacturers, say, hey, what should I apply in this application? I'm sure they would be happy to help you. And then you've got all of the different applications. And again, I'm telling you that the number of applications you will find a receptacle in are significant. And the environment in which we place all of these receptacles is also significant. Think about the difference between a receptacle that's placed in a marina versus a receptacle that's placed in your living room. Two totally different environments. One is going to be subjected to all kinds of horrible weather. Unless you have a house that, sort of floods. But in any case, you'll have receptacles outside, you'll have receptacles in and around saltwater or any type of marine application. You'll have receptacles put on equipment that moves. Maybe it's drugged down a highway. There's so many uses of receptacles. It's insane. And that's why it's so important that we understand what a receptacle is, what is the proper application, and take a look at how it's tested. The paces that we put the little wiring devices through is considerable. Now, they're not without weaknesses, right? You can't use a receptacle that's not designed for a function and expect it to deliver that function, just like any electrical product. I can't rely on a thermomagnetic circuit breaker to detect arcing and sparking. It wasn't designed to do that. There was no test developed to say, I want to see if it can do this. So receptacles have similar things, similar aspects about them. They are designed for a purpose. They are designed for a function. They're not going to provide overload protection for your products. Just because they may trip on GFCI does not mean they provide overload protection of anything. They provide some ground fault protection, and they might keep your heart from going into defib, but that's ancillary. All right. So what we covered. What did we cover today? I think we covered some things, and I'm fading fast over here. Remember the Germany experience here with wiring devices. There's no push to test button in the bathroom on GFCIs. What they do in these applications over here, they have a 300 milliamp on the main, on the service overcurrent device. Then they have 100 milliamp, 30 milliamp on the branch circuits. So all of these receptacles here are protected at 30 milliamps. But there's no push to test button in this room on any of these receptacles. I can't test them. And I'm not going to try to test them. I don't have a tester, because then where's the breaker at, right? So or where is the device that gives it 30 milliamp ground fault protection? That's what I got to think about. So these devices, we rely on them for many applications. They're in many types of structures, and they're used globally across the world for plugging in equipment. And if you are traveling abroad, you're going to need these types of products that help you adapt to the environment with your electronic piece of equipment. For example, I have a cord for my MacBook Pro, but it has 3 prongs, and the product that we have over there does not have 3 prongs in it. This one does. So I have to plug the adapter into the wall, then plug this adapter into that adapter to be able to use a 3-prong plug. But what I did was I removed the 3-prong plug from my power supply on that MacBook Pro and they have an insert that you could just put in there that has just 2 prongs. And that works perfectly fine with that application. In fact, I'm powering my computer as we speak. All right, so some links, and I'll put the links down below just to wrap this up. Receptacles are important. Consistency is important and is critical. It's important that we understand the differences between, say, a hospital grade and a standard grade, etc. Here are some more references. NEMA WD6. It's wiring devices, dimensional specifications. It is a free download. Link is down below. NEMA document, protection of receptacle outlets in wet locations according to the National Electrical Code. Another cool reference. That's down below. A NEMA WD1 general color requirements for wiring devices. Now that's going to be interesting. If you want to know what the general color requirements are, that's the standard to look at. If you're doing things like healthcare, Article 700, or fire pumps or fire alarm systems, you need to understand that. UL listed hospital grade receptacles and the differences between grades. That's another big topic. And hopefully we got a little bit out of our discussion today. And then finally, the UL White Book, RTDV, and then RTRT. So that's all about receptacles. Hopefully you got something out of our session today. Remember, I'm looking forward to you joining IAEI. You got to get out there and join. If you're not a member and you're watching these, please consider joining the International Association of Electrical Inspectors. The IAEI is a great organization. I just did a few presentations here recently, and I keep asking people in the audience. The last one I was at, there was only one person in the audience besides me that had an IAEI membership. So get off your butt. Get out there and get your IAEI membership, because membership has its values. So as we move into and take this YouTube channel to the next level, you're going to have opportunities to maybe get a membership of the YouTube channel. I don't know. Stay tuned. So hopefully you got something out of today. I really appreciate you staying with me and hanging in there. And I am fading fast after many hours of not sleeping. So that's all I had. Hopefully you got something out of this program. And hopefully you look at the receptacle a little bit differently this time. All right. So please, I really enjoyed it. Keep the text, keep the chatter going. I know I'm recording this and I'm not even watching the chat. And I know you're fired up and you're chatting it up. You're talking about all different things related to receptacles, and you're basically sharing all your knowledge. So please do that and enjoy. And I hope you have a great rest of your day, and I hope you have a great week until next week for the next IAEI News Live. My name is Thomas Dimitrovich, and I'm signing out. I appreciate everything you do for the electrical industry. I appreciate your time and your dedication to watching these programs and commenting. Thanks for what you do, and thanks for what you do for electrical safety. Remember to stay safe, and please, by all means, stay healthy. Be careful.